rebuilt the rotor brush motor that we bought from Wes. We were told everything was fine with it. I took it apart. I did not follow manufacturer specs because the motor in there can be wired several different ways. Wire it back to the manufacturer specs. It works perfectly.
Nice. Nice. Now let's do some testing. Get your meters out. Somebody's missing a light. Who's missing a light? You missing a light?
Yeah, but also we need another three-way or something because there's no power.
There was power. What happened?
We brought another board over here.
Ah, okay. Go in that bag right there and you'll find some splitters. Take one out of the new one out of the package. So y'all got your lights turned on, other than him? Take them off and you measure volts AC from this point to this point here. Got good volts there, right? Yeah. It's a night light, plugs right in the wall. It's not that much power, it's just voltage. This could be a 480 volt light, 126. We got full voltage going there, right? Now there's a little switch on your lamp. Turn it off. Leave everything else the same, just turn that one little switch off. Now measure voltage again.
Same.
What you've just done is you've simulated a broken light bulb. We're applying voltage to the load, but the load's not working because now it has an open circuit because of that little switch. We just broke our light. This is how you know right away whether or not there's a problem with your circuit or whether there's a problem with your light. When you measure voltage at the load, you do have voltage, but the load doesn't work. There's something wrong with it.
What happens when your outlet's broken? When you have one works and one doesn't?
Excellent.
Yeah, you're right.
I didn't tell you to put your pros in the outlet, did I?
Yeah.
All right, turn your little switch back on. Would you like to put it up?
Together.
Turn your switch off. Turn your control switch, this one here, turn that one to the off position. Open your switch. Awesome. Okay. So, now measure for the presence or absence of voltage at the load by measuring across the load like you just did. And of course you know you're going to find zero. You already know that. So now we're doing the troubleshooting scenario. I don't even need to worry about the load at this point because it's not even getting what it needs to survive. It doesn't have what it needs to operate. I would not expect it to be operating in this condition. I don't even suspect it has a problem. My question is, why does it not have voltage? We're going to pretend for a minute that the switch shows that it's in the on position, but I don't have voltage in my light. So the next idea is to identify where am I losing my power from? Where am I losing voltage? And we're going to do a process that's known as walking the line. We're going to walk the line. So we're going to start at the end of the circuit at the load, like here. We're going to start here, and we're going to start walking backwards through the circuit. So having the schematic diagram in front of you is really helpful to know exactly where to test next. So the next place I want to test is I want to keep my black lead over here, and I want to move my red lead over to here. And that's going to test the integrity of this wire. So move from here to here. In your case, that would be probing from here to here. You still have zero. So now you move to the next possible point from here to here, leaving your black lead over here where it was. And you realize
No,
right.
this one.
That means they actually installed it. That's the opposite they have. Or is it
Most of our HVAC switches don't say on or off on them, and you can't tell by looking at them whether they're open or closed. This is how you tell. If this were a contactor, and this were a pressure switch, I can't tell by looking at the pressure switch whether it's open or closed. I can measure the pressure to see if the pressure is appropriate, but that doesn't tell me if the switch is open or closed or not. My question here is the switch bad, or is there some other problem? I don't know yet. I gotta find out where am I losing voltage. In a typical circuit, there's going to be multiple switches in series with one another, and I need to find out which is the one that is stopping my load from working. And this is how you do it. From point. Now when you got here, this is when voltage appeared, right? No voltage, 120 volts. This tells you that between this point of test and this point of test, that's where your problem lies. And what's in between those 2 points? A switch. Your problem is your switch. Your switch is open. Now, if your switch is showing you that it should be closed at this point, such as it's a pressure switch which has the normal amount of pressure behind it, the switch is bad. If the switch is open and it's a pressure switch and I measure pressure and I find 0 psi, I have a pressure problem. So suddenly I have a mechanical problem, but I started checking it electrically. But I found that it was a mechanical problem by checking it electrically. You always check electrically first, and then it will reveal what source of mechanical problem you might have. That make sense? Cool. Any questions? Unplug your boards, please. Unplug your little lights and set them aside. Draw a new schematic diagram, preferably on a new page or next to the one you just drew. Begin with the power supply, represented by L1 in a circle and N in a circle. Start off with a load. Now we're going to have 3 normally closed switches. All in a row.
Close.
I'm sorry, 1 normally open switch, 2 normally closed switches. Remember over here, off equals normally open, on equals normally closed. So on your side, you're going to be using 3 of these. 1 of them will be in the on position, the other 2 will be in the off position. If you realize that some of your wires can stay where they were. Like the wire that goes from your load back to neutral can stay where it was. That's not going to change.
On L1 to
The wire that's going to go from L1 into your switch won't change. Now we're going to take from one switch. So this one here is going to be off. This one's going to be on, and this one's going to be on. We go from one switch to that one into that one, and that one back to the load. Fire it up. Anybody need to come and get a closer look at this step down?
So you're going to
Ready?
That's what I grew up on. It just take a chance to make me sleepy.
This is your voltage power.
In and out.
High and neutral.
In and out of the.
I'm ready. What's the question, Ben?
Okay. So that's the source.
Mark.
Here.
He didn't tell you to plug that up.
Why couldn't I even load that one? That's the part I could.
There's no difference whatsoever. The switch doesn't care what direction voltage or power goes through it. It has no difference between in and out. There is no gazinta and comes out. It is whatever it is. So you could flip these two wires around and it would function exactly the same.
Except for this position would be first.
No.
It only matters because it's single phase, right? Because it's single phase, it doesn't matter.
No, because switches don't care. All a switch does is it goes from open to close. If the power source is on my right elbow, it will go from right to left. If the power source is on my left elbow, it will go from left to right. It makes no difference whatsoever.
And I mean, as far as the orientation of it actually stating on or off. Because this switch, on the one position, it breaks the content if this is in the on position, then it's a So, if I was to then switch my wires, that would reverse that orientation.
Because you're looking at this. All this has is a lever that makes this happen.
So I'm